So on the piece of paper that you have on your desk, what do you have at the top of it? Vocabulary. What do you think we're going to put on here? Oh, vocabulary. You were. See, this is why I knew you were pre-AP. That's how I knew. All right. There's two vocabulary words that you already know what they mean, but you may not know the words that attach to the meaning. Okay? So the two words that are kind of our focus today . And I don't want to hear any comments about how that's really three words. You be quiet. Set builder notation and interval notation. Those are the two things that we're focusing on today. But like I said a minute ago, you already know these things. Okay? Now, in English class, when you are building a vocabulary to be able to speak better and to be able to write better, what do we immediately write after a vocabulary word? The definition, right? That's very logical, okay? In math, sometimes we're going to write the vocabulary word and the mathy math definition, okay? Sometimes in math, especially in this situation because you already know what it is, I just have to convince you that you know what it is. Sometimes all we're going to do is write examples so that when you see it, you're like, oh my gosh, I already know what that is. And I would be like, I told you that, right? You already know what it is. We've already discussed it for 2 days, in fact. Okay? So let me prove to you that you already know what this is. All right? On a number line, you don't have to write this down, but on a number line, if I'm going from 2 to 5, oh, okay, are you guys okay that I didn't put 0 on here and then I didn't put 1 and then 3 and then 4? Okay, good. So if I'm going from 2 to 5 and I have a colored in circle there and a colored in circle there on 5 and I'm talking about all the numbers in between 2 and 5 and I said to you this goes from 2 to 5. Have we talked about something like that before? Remember using brackets? What else did we use besides brackets? Parentheses. What would it look like if I needed to use parentheses? An open circle. I don't know if you can see the highlight up on the screen. If I made that an open circle, oh wow, you can really see the highlight up on the screen. Okay, that's good to know. If that was open circle instead, it would look like 2 to 5. That is interval notation. Okay? What we talked about was we had a graph that looked like this, right? And we said, what's the range of this? Well, how far down does it go and how far up does it go? It goes from 0 to infinity. That's the kind of stuff that we talked about. Is that an easy transfer to go from here? Yeah, right? We've talked about this. We're going to transfer it to just a number line today. That's why what we're doing today is what? Writing domain, right? We're writing domain. We're going to write domain because we're only talking about a number line. We're only talking about our x values, okay? But there's more than one kind of notation, isn't there? There's interval notation like this is, and there is set builder notation, okay? So first of all, on interval notation, I want you to write this, the 2 comma 5, and I want you to write the 0 comma infinity with the correct, this one both having 2 brackets and this one having a bracket and a parenthesis. Is that enough for you to look back at this vocabulary page and say, oh yeah, that's interval notation? Okay, good. So here I'll model for you what I would like. Okay, I mean not my clothes, they're nice, but I'm talking about the math. I'm modeling the math. Okay, so we're going to put 2 comma 5 and we're going to put 0 comma of infinity. Okay, questions about that? So those of you who know me, have known me for a while, know that I like to say the right things, right? I don't like to make up words, right, Philip? Okay. I like to say the right things, all right? And I have to be honest with you. The other day when we were talking about set builder notation, which is our other vocabulary word, I got lazy. Do you remember what it looked like if I was writing the range of this function right here? I said x is, or excuse me, range, so y, pardon me, y is greater than or equal to 0. Do you know what I mean by that? Yeah, right? But you need to understand that's lazy. That's not really set builder notation. This is set builder notation. First of all, I use pretty braces, and then I tell myself, self, we're talking about y's such that y is greater than or equal to 0. This is appropriate set builder notation. Okay? This is not wrong, it's just lazy. And I'm not letting myself get away with being lazy, and I don't want to let you get away with being lazy either. Okay? So we're telling ourselves, we're talking about y's. So we're talking about ranges. I'm not talking about x, I'm not talking about lambda, I'm not talking about eta, I'm talking about y. And then let's talk about what the specifics are about y. Y has to be greater than or equal to 0. Okay? Yeah, that's really all we need to talk about there. Let's see. All the range. Did we have any ranges, did we have any domains the other day that were not all real numbers? I think most of them were all reals, weren't they? Okay. I'm waiting. Oh, square root, right? Square root. Okay. So if we talk about a square root function, it goes like that, right? Oh, that's ugly. Just don't judge my graph. Just know what I'm talking about, right? How would I write that in set builder notation? That domain. Yeah. Braces, x, such that. Guys, that's just a vertical line. It's not a 1 or anything like that. It's just a vertical line. X such that. Very good. X such that x is greater than or equal to 0. That's it? Oh, brace. Any questions about that? Okay? So I want you to put one of the other, or both if you want to, of these as our example for set builder notation on our vocabulary page. Most of the time what people forget is which one is which, not how to get them. They forget which one is which. Okay? Any questions about that? So let's apply it. On page 4 of your book. First of all, is there anything on page 4 that's familiar? Oh, we made that, but ours was better. Okay? So you have that in your notebook to refer back to, and you may need it today if you don't remember what a whole number is compared to an integer or a natural number. Okay? So one of the reasons that we chose these books is because they have really good examples. They say core concept. If you know anything about English, first of all, it's bolded and it's bigger, right? What is it telling you about the information here? It is important, okay? Not only that, but there's highlighted stuff there, right? Usually in your other classes, the highlighted stuff are the vocabulary words, right? I think you guys are okay with these. I mean, correct me if I'm wrong, but I think you're okay with these. It's the interval notation and set builder notation, set builder notation that I chose to use as the vocabulary words today. Okay, so I'm going to go kind of quick through these core concepts, not because they're not important, but because you have them to look back at if you need help, because they're right in your book. Okay, so if this is the given inequality, does this make sense that it's the interval notation? Why are there brackets and not parentheses? Because it's closed circles on the graph, and because the inequality says less than or equal to, right? When it's or equal to, it's included, and we have a bracket there. Okay? These are called bounded intervals. Any guesses why they're called bounded intervals? Let me show you this real fast, and maybe that'll help. On the top of the next page, these are called unbounded intervals. Can you compare them and figure it out? These, the first ones has points on both ends, an ending point, a starting point and an ending point, right? This one has maybe a starting point, but this bottom one, it has all the points, right? All the points are part of the answer. So at one point, either the right side or the left side goes to infinity, right? And you can even notice that here in the interval notation as well, all right? So this is what the inequality would look like. Here's the interval notation, and here's what the graph would look like. In your homework today, I might give you the inequality and ask for the graph. I might give you the inequality and ask for the interval notation. I might give you the graph and ask for the interval notation, graph, inequality, blah, 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 right? So that's why it's important for you to look back at these if you struggle at all, because all the help you need is right here, okay? Now, I'm not saying I won't help you. I think you know me better than that, okay? But use these core concept boxes to look back at if you're struggling. Okay. Last core concept box is on the top of the next page, where we talk about set builder notation. Okay. Now, people today have struggled with that word right there. What word is that? Or. So I've said, let's pretend this A is a 1, and let's pretend the B is a 7. Somebody please tell me a number that is less than 1 and greater than 7. There's not any numbers that are less than 1 and greater than 7, right? So there's not a problem with this graph. The problem is how we're looking at it. A number can be less than 1 or greater than 7. And according to this graph, all the numbers less than 1 and all the numbers greater than 7, not counting 7, are solutions to whatever situation is happening here. Okay? So that's why we have to use the word or. And it's okay to write the word or. That's all right. Okay? I know this is math and you don't want to use English in here, but, you know, sometimes we have to mix them. That's how we're becoming bilingual, right? All right? So very quickly, look at problem number 3. So this is one of the few places they're like, hey, do this one. Except we haven't seen an example of stuff like this yet. So that's why I'm going to go through it with you real quick. It says, use braces, these things, to list the elements of the set. So number 3 says the set of whole numbers less than 10. First of all, can you tell me what are the whole numbers less than 10? 0 through 9. Can I just write like 0-9? Or do I have to write all the numbers? Is it asking me for a list? Use braces to list. Okay? So for number 3, if I was doing number 3 in my homework, I would write number 3. The set of whole, if I can spell whole correctly, numbers less than 10. And then I would use my braces and I would just start writing the whole numbers less than 10. In what order? So least to greatest, right? Numerical order, least to greatest. Okay? So what'd you say it was again? 0. Why didn't you say 10? Oh, less than, oh, you are so right. Okay? Now, when I wrote this earlier, guys, somebody said, why didn't you put the X? Because remember when we did set builder notation earlier, I'd had to do the X? First of all, are there any X's in here? So I'm not dealing with a variable, so I don't have to have a variable in my set. Okay? Any questions on how to do things like that? What about number 7? If I'm doing number 7 on my paper, I'm going to write 7. I'm going to write 3 is less than X is less than 9. The directions ask me for interval notation. If I struggle with interval notation, I can very easily go back to the core concept page where it gave me an inequality that looks like my problem. Can't I? 3 to 9, both less thans. So I know my interval needs to look like this. Parenthesis 3, comma 9, close parentheses. Done. Any questions? Okay, so just so we're clear, your homework problems are on page number 7. You're doing problems 3, 4, 7, 10 through 14, 17, 19, 21, 24, 25, and 31. It's your call. This will go in your notebook under homework. So if you put a little notes on the top of it, you may want to put that in notes and make a new sheet with the homework. Okay, but I did model this for you how I want. I want the problem written down and then the answer. Most of the time it'll be the problem, the work, and the answer. But honestly, what work is there here? It's just the problem and the answer. Okay, so even if it's a graph, like on number 11 or 12 or 13, I want you to go ahead and draw the graph. Okay. The last thing is make sure you write this on the top of the paper, which problems to do, because after a while I'm going to take this down. Okay, I'm going to take it down. It's also on the sideboard, but I did go ahead and write it on the paper, basically for the people who are having to watch the video later, because there's really no way for them to know yet. Okay, does that make sense? You can. Pardon? Yes. Okay, this paper, there it is. This paper will go in your vocabulary section, and we'll add to it as we go throughout the year, okay? Any questions?